Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month for the end of February 2023. My name's Dave McDonald, and I am your host. And what we're going to do for this part, the second half of February, beginning of March, we are going to talk about some numbers that we often talk about on the show when we talk about, like when you look at Jupiter, it appears as though it's like 36 seconds of arc. What does that mean? Some of you know, some of you don't. But what I want to do is demystify some of those numbers that you hear when you hear things like minutes of arc, seconds of arc, degrees. People pretty much have a handle on. So I'm going to tell you some information right now about the planets, and then I will demystify with a couple of diagrams what those numbers mean, and then I'm going to retell you the information about several of these planets. And then, of course, as always, towards the end of the show, we'll be talking about the constellations, the stars, and the planets that you can see in the night sky and where you can find them. Don't forget to check out the McAuliffe Shepherd Discovery Center's website, because there's a great program every first Friday night of every month. Go to starhop, starhop.com, and look for Super Stellar Friday. It's the first Friday night of each month. And just looking way ahead, June 2nd, I will be doing a special program at the Discovery Center unveiling the mysteries of the zodiac. So get yourself that on the calendar right now, Friday night, February 2nd. But check out starhop.com. We have a brand new planetarium show relative to the Abenaki Pennacook Band here in the Concord, Merrimack Valley area, and it's a great show. But check it out, starhop.com, and hope to see you there. Okay, so planet-wise, Venus, you may have noticed in the western sky, there's this bright, blazing object in the western sky after the sun sets, and that is the planet Venus. And Venus is blazing at an amazing negative 3.9 magnitude. Now, another time we'll get into magnitude, but briefly, magnitude is a measure of brightness of celestial objects. When you look at an object, it appears to be so bright or so dim, and we put numbers on the brightness or dimness of the objects. The lower the number, or the more negative the number, the brighter the object. So Venus is at negative 3.9, which is very bright. Every number, every whole number, is about 2.5 times brighter or dimmer than the previous number. So, for example, a negative 3.9 is 2.5 times brighter than a negative 2.9. So, the brightness of Venus, negative 3.9 magnitude. Now, when you look at it, it just looks like a point of light, a bright and maybe kind of a blazing point of light because it is so bright. But if you have a telescope and you look through the telescope, you'll see a discernible disk there. And that disk that you are going to observe in February is going to be 11 seconds of arc. And I'll explain what that means in just a moment. Then as the month goes on, as we get towards the end of the month, it's going to get larger to 12 seconds of arc. But as we start the month, it's 91% lit, and as we get towards the end of the month, it's going to be 86% lit. So why the discrepancy of the numbers? Well, try to picture, if you will, Venus is coming around from behind the sun, and it's getting closer and closer to Earth as it comes around the sun. So as it comes around the sun, it's getting closer to Earth, and that's why it goes from 11 seconds of arc to 12 seconds of arc it's getting closer, it's going to appear bigger. But if you think about the phases of the moon, as it comes around the corner of the sun and gets closer to us, less of it is lit up. So it's only 5% difference, but it's a difference that you can notice. And as time goes on further into March, it will be less and less lit. And Galileo was the first really to notice this with his telescope, and this was one of his proofs that Earth goes around the sun rather than the sun around Earth, or that Earth was not the center of everything because Venus could not go through these phases of changing its percent brightness the way it does. If the sun is the center of the universe, and Earth orbits the sun, and Venus orbits the sun, it's all explained perfectly well. So that is one of the things that got Galileo in trouble. So Venus is coming around, and it's going to be 11 seconds of arc to 12 seconds of arc in size. Now, in terms of Venus and Neptune, Valentine's Day, February 14th. Don't miss this opportunity. You need to get yourself some binoculars, because one of the special things about February 14th is you're going to have an opportunity to see the planet Neptune. You need binoculars, though. It's not a naked eye object. You need a small telescope is better. So now listen to some numbers here. Okay. Neptune is going to be shining at 7.8 magnitude. Now the limit of human visibility for most people, when it's clear, is a magnitude 6. Remember, the higher the number, the dimmer the object. So a magnitude 6 is 2.5 times dimmer than a magnitude 5. And a magnitude 6 is 100 times dimmer than a magnitude 1. So Neptune is a 7.8. So you need binoculars to be able to see it. But it's going to be within 33 minutes of arc in terms of its angular distance from Venus. So because Neptune's so hard to find, this is a great time, February 14th. And February 15th is also good if it's cloudy on the 14th. February 15th works just as well, except they're just a little bit changed in position. So Neptune will be a little lower than Venus, whereas the 14th is a little bit above Venus. And I'm going to show you where. Later on in the program, I'm going to show you exactly how that works. Okay? So that's a little bit about some numbers. And through a telescope, Neptune is going to display a 2-second a 2-second of an arc. Hard to believe. So that's about 1/6 the size of the image that you'll see of Venus. It's discernible, but it's a real small circular disk with an angular measurement of 2 seconds of arc. Okay? So let me more information about some of the other planets, but let's just dig in a little bit to what these things mean, okay? So let's look at this slide here, and you can see we're looking at the moon. And the angular diameter is like if you were looking up and you were to put one edge of a line of your protractor, if you will, to one side of the moon, and you measure the other line of your protractor to the other side of the moon, you get what's called an angular diameter, right? And that angular diameter for the moon, as you look at it, happens to be about 1/2 degree. So if you look here, look at my protractor here that I'm holding. I'm just holding it against my laptop cover here. Okay, so you have one of these protractors. Every school student has a protractor. You can certainly buy one. But if you were to take a piece of paper and you were to measure from 0, because notice that the 0 line is kind of in the middle of the plastic. It's not right at the bottom. But you see where the 0 point is, and then the first little line, 1 degree. So put a dot at the center, measure 1 degree, so a dot at 0, a dot at 1 degree, and then orient your paper so that you can get these two lines going across your paper, and obviously these two lines are going to diverge, and the further away they get from the point of the angle or the vertex of the angle, the further apart they're going to be. And if they keep on going and going and going, that's an angular measurement of 1 degree. So the moon, if we can go back to the moon slide, the moon is about 30, roughly, on average, 30 seconds of arc, and that's half of a degree, right? There's 30 minutes in an hour. There's 30 minutes, sorry, I take that back. There's 60 minutes in an hour. There are 60 minutes in 1 degree. 60 minutes in 1 degree. So 30 minutes, if you're talking about time, is a half an hour. 30 minutes with angles is a half a degree. Let's do the next slide. And you can see here, again, the angle coming from a point going to some object, whether it's the moon or a planet. There's a distance there, and the size of the angle is like going from your eyeball to one side of the object, the moon or the planet, to the other side of the object, the moon or the planet. And in the real night sky, you can't really tell because things are so far away and it's just a pinpoint. But with a telescope, you can see a discernible disk. Now the moon, you can just look at it and it's no problem. Okay, next slide. And so degrees. An arc minute is 1/60th of a degree because there are 60 minutes in 1 degree. An arc second is a 60th of an arc minute, right? Because there's 60 seconds in 1 minute. So how many seconds are there in an hour? Well, there's 60 minutes in an hour. There's 60 seconds in a minute. 60 times 60 is 3,600. So 1 arc second is 1 3,600th of 1 degree. And if you want to put a calculator, here's just a few things up there. If something was 28 minutes of arc, you could figure that to be 0.467 degrees. Okay? Remember, 30 minutes would be exactly half of a degree, or 0.5 of a degree. So those are just some numbers that give you an idea. Right? So next, the angular size, again, has to do with how far away things are. The further away things are, the smaller the angle will appear to be. Now, obviously, the size of the object does not change. Okay? So this goes back to 2003, these images of Mars. And this is something that shows up sometimes on websites. Mars is going to be larger than a full moon. And in 2003, when we had the closest approach to Mars in some time and some time to come, the idea was that through a telescope, the image that you see of Mars would be larger through a telescope than looking at the moon in the sky. Mars is not going to appear larger than the full moon in the sky. So you can see that August 27th, 2003, Earth and Mars are really close to each other. So when they're really close to each other, Mars had an observable disk of 25 seconds of arc, which is a good size. And then you can see in the diagram to the left, when Mars is further away from Earth, like on January 2003, the distance is further away, then your image or the angular diameter of Mars is going to be only 14 seconds of arc, and the average being 19. Okay? So that was that year when Mars was in general closer. It's not so close anymore, and so for right now, you can look at Mars up in the sky, and if you had a telescope right now in February, the beginning of February, Mars is going to start at an 11-second of arc disk, but it's going to diminish to an 8-second of arc disk by the end of February. So that's some information relating the diameter of objects to Mars. And speaking of magnitudes, Mars is going to be shining on average throughout the month of a negative 0.2, so really close to 0. 0 is a very bright object, so negative 0.2 is just a little brighter than that bright object. And a magnitude 1 star would be, a magnitude 0 star would be 2.5 times brighter than a magnitude 1 star. And I'll point out some of those stars for you later towards the end of the show. Okay? So next, getting back to our angles here, you get the lunar size. The angular size is the angle that an object appears to span in your field of view. Now, the moon you can just look at and get an idea, but some objects like planets, you need a telescope. The further away an object is, the smaller its angular size, but obviously its actual size doesn't change. So next, the mean radius of the moon is 1,000, just about 80 miles. Right? Its distance varies. Now, there's a word named perigee that we can learn, and that is when the moon is closest. Perigee, closest. Apogee, furthest. I think of A away, right? A away is furthest away in terms of its distance. So it ranges from about 225,000 miles out to about 252,000 miles. And so when we look at the moon, its angular size changes, or its angular diameter that we look at changes. When it's closest, it's about 33 minutes and 30 seconds, so basically 33 and a half minutes of arc. And when it's furthest away, it's smaller at 29 minutes and 26 seconds. And you can see in the pictures there, you can see that the moon appears to be a little larger, appears to be a little smaller. And on a topic for another day, that has to do with supermoons and smaller moons. So supermoons are when the moon looks particularly big, and that's when you have a full moon near perigee. Okay? Next. These are, if you look at the second line of information down, like you have February 15th, and then the next line down, you have the magnitude average for the month. That's how bright things are that we talked about. And then the next line down, you have the angular size. So you can see Venus's average is 11.6 seconds, Mars 9.3 seconds. Again, that's the average because I told you it's ranging from 11 down to 8. Ceres is the dwarf planet that is in the asteroid belt. It's the largest asteroid, 0.8 seconds of arc. We'll look all the way to the end at Pluto. Pluto, way out there, 0.3 seconds of arc. And you need a decent, a medium-sized telescope to be able to see it. Okay? But notice Jupiter, largest planet, 35 seconds of arc. And throughout the month, it's starting the month at 36 seconds of arc, and it's going to be diminished to 34 seconds of arc, and there's the average, 35.0 seconds of arc is what you're going to see for the angular diameter of Jupiter. And Saturn, the disk itself is around 15, but when you add the rings to Saturn, it's comparable to the size of Jupiter. So I hope that gives you a little bit of an idea of how angular measurements work. You have your protractor, and you can measure a degree. Half of a degree is 30 minutes, because there's 60 minutes in 1 degree, 30 minutes and a half a degree. And then each minute is broken down into 60 seconds. So 60 seconds for every minute. There's 3,600 seconds in a degree. So that's how that works. And if you get a chance to look through a telescope, then that will help you understand what you're looking at. Because if you look at Jupiter and you understand that's about 35 seconds of arc, and you look through the telescope, you say, okay, that's 35 seconds of arc. You look at Venus at around 11 to 12 seconds of arc, and you look through a telescope, you get an idea, okay, that's what that is. And if you get a chance to see Neptune, which is 2 seconds of arc, remember that's February 14th, then you'll see, wow, that you can just barely tell it's a circular disk there. Okay, so hopefully that was some helpful information. Now what we want to do is show you the night sky and show you where you can find some of these things. I mentioned to you the planet Venus and the planet Jupiter. They're going to be getting really close together on the last day of February, February 28th. So let's take a look at the night sky. Well, I hope you enjoyed that information about the seconds and minutes of arc and degrees and such. And now let's look at some of the planets that we were talking about. So notice here Venus, blazing Venus. Now, I don't have the name up, but those little like red pointers that you see there are pointing not at Venus, they're pointing at where Neptune is. So you can see how close Neptune is to Venus. This is February 14th. Happy Valentine's Day. It's like Neptune is kissing Venus. Where did I get that from? So February 15th is a good chance as well. Neptune is going to be a little bit lower underneath Venus, but really still very close. On the 14th, it's 33 minutes, which is about the width of a full moon. And then on the 15th, it's going to be, again, Neptune's going to be a little lower, but 40 minutes of arc, which is imperceptibly different, really. So either the 14th or the 15th are your opportunities. Notice they're close to the horizon. They're in the glare of the sun. We're looking west about an hour after sunset, maybe 45 minutes after sunset. You need binoculars. You'll see Venus, no problem. But to see Neptune, you have to have binoculars. Small telescope is better. And then, of course, Jupiter. Jupiter is a negative 2.2 magnitude. Venus is a negative 3.9 magnitude. So there's almost 10 times difference in the brightness. Venus would be almost 10 times brighter than Jupiter. So this is February 14th. Now we're going to go 2 weeks later to the end of the month, February 28th. And now check out what's happening on February 28th. We're looking at Venus and now Jupiter, because Venus has been coming up out of the sun. Notice that we don't have a glare of the sun there. Okay, so this is about 6:30. So we're a little later after sunset, about 6:30 in the evening, February 28th, and you can see Venus and Jupiter. Two very bright objects, very close to each other, and that's going to be a great night to be watching as well. And again, February 27th, February 28th, March 1st, in that area they're going to be really close. The closest being February 21st. And if you keep on watching through March, well, we'll talk about it, Venus is going to continue to rise and Jupiter is going to continue to go down. So they're going to be exchanging positions. All right? So we're going to stay the same night, February 28th, and check this out. So we've got some great constellations to show you. This is, again, the 28th. The moon will be out and very bright and very visible. And I want to talk about one constellation in particular. So we have the twins here, right? Castor and Pollux. Pollux, the name is there, but this is the star Castor. And the star Castor, I remember of the two, because it's closest to the bright star, the 0 magnitude star Capella, which is a yellow star overhead. It's off of the screen. But when you go out at night, and this is right here about 8 o'clock at night. This says February 28th. But, you know, the last couple weeks of February, the first couple weeks of March, we're in the same area of sky that you can see all these things, except the moon is on the move because it moves every night. Now, one thing that you can determine how far the moon is moving is if you take your fist and you hold it out in front of you. You see where my pinky part of the fist is against the moon? Well, where my thumb is, or actually the way I have it positioned here, where my pinky is, that's where the moon will be tomorrow night. It's about a fist's at arm's length distance towards the east. The moon moves from west towards east against the background of the stars. So we have the twins here. Castor and Pollux are the two twin stars. And easy to find because Orion is the easiest constellation in the winter to find. And you find Orion, Betelgeuse, magnitude 0. Capella, I mentioned to you, overhead, yellowish, is also a magnitude 0. So you have something to go by. Aldebaran, the eye of the bull, is an orange star. It's a magnitude 1. So magnitude 1, Betelgeuse then is 2.5 times brighter than Aldebaran is. Capella is a magnitude 0, which is overhead, 2.5 times brighter than Aldebaran. The twin stars, Castor and Pollux, they're both about in the realm of magnitude 1 stars as well. They're white stars, though. They're decidedly white. And you come down to Procyon, the little dog star, and then you come all the way down to Sirius, which is the brightest star in the night sky, and you can take the 3 stars of Orion's belt, go downwards, and you come to Sirius, which is a magnitude negative 1.44. That's the brightest star in the night sky, negative 1.44. So you can see the planets can be brighter. And needless to say, the moon is a lot brighter. It's like a negative 12 when it's a full moon. Okay? So we find Castor and Pollux, the twin stars. Now, if we keep on moving towards the sickle of Leo, the lion's head here, you can see this. It's almost like, I call it the backwards question mark here. Right? That's the lion's head. But in between, there are some not so bright stars that make up Cancer, the crab. But I want to show you something neat and special about Cancer, the crab, because right around in the middle of the crab that you can perceive there's like a fuzzy spot there. That's Messier Object 44, called the Precipice from ancient times. And in more modern times with telescopes, it's called the Beehive. So let's look at the next slide. And you can see the beehive cluster here. So this is the exact same image that we were just looking at, but we just took the artwork away, right? So we have Castor and Pollux here, Procyon, the little dog star, and you can see it kind of makes a triangle with, and you can see it naked eye, binoculars will help. But you can see this fuzzy spot called the Precipice or the beehive cluster. Now, if you have a small telescope, and you look at the beehive cluster, the reason it got nicknamed the beehive cluster is, well, guess what it looks like. Next slide. It looks like a bunch of busy bees. So this is M44. This is the beehive cluster. Binoculars will help. A small telescope will help even more. And if we were even to zoom in further, then we see, the next slide, more individual stars, and they have color. What a beautiful, beautiful image it is. The Beehive cluster, M44, the Praesepe. It's in the constellation of Cancer the Crab. A dim constellation, but worth taking some time to navigate through the stars and locate the Beehive cluster. Well, I hope that you enjoyed the show. You learned some great things. It's been a pleasure being with you. I'm your host, Dave McDonald, and this is The Sky This Month.